Okay, guys, geometric sequences now. So now instead of adding each time from one term to the next, we're going to multiply. So you look here, I have 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. But let's make this, I can just change this up a bit. I'll use 3, 6, 12, 24. That way we don't have 2 as our first number and 2 as our multiple. So I have 3, 6, 12, and 24. And you look at this and you say, well, there's a ratio here, a common ratio. I'm multiplying by something. That makes it geometric sequence here. How do I know what the number is? Okay, it's times 2 times 2 times 2. But one way to look at it is to say, okay, 24 divided by, if I go 24 divided by 12, I get 2. Okay, if I go 12, sorry, I'm having some issues here. 12 divided by 6. So if I take this term and divide it by the term in front of it, I figure out what my ratio is 2. 6 divided by 3 is 2. So my ratio in this case is 2. My first term, which we called A, and we called it A last time, is 3. So R is my ratio. And let's figure out if we can come up with an equation for the general term. My first here, T1, is just 3, or A. Then I have A times R for my second term. So I have 3 times 2 is 6. My third term is 12. That's A times R, or A times R squared. Okay, if I had a fourth, T4 is A times R times R times R, or A times R cubed. Okay, so what's happening here is for any term, I'm multiplying A by R to the power of N minus 1. So that's the fourth term, power of 3. Third term, power of 2. Second term, power of 1. We don't see it here. Even this one works. Power of 0. Remember that R to the 0 would just be 1. Okay, so when I look at this here, that's how I come up with the general equation. You don't need to memorize that. You'll be given that. And that's it. If you want to figure out the 14th term of this sequence here, 3, 6, 12. So we already did this. We already started off with the same number. Is here. A is this. R is 2. 6 divided by 3. 12 divided by 6. That's 2. If I want to get the 14th term, I want T14. So my equation was Tn is A times R to the n minus 1. Same with this. Then I have A R n minus 1. A is 3. R is 2, I said. So that's 2. N minus 1 is 13. 2 to the 13. Throw that in the calculator. Multiply that by 3. And you get 24,576. Okay, that's your general question there. If determine the 12th term here. So same question here. I still want to find T12. So I'll use this formula right here. And this will just be, I need A and I need R, and then it's going to be, it's going to be to the power of 12 minus 1, which is 11. So let's figure out what A and R are. A is my first number, which is 2 again. And then I have R to the 11th. What's my R? Well, it's minus 10 divided by 2, which is minus 2. It's 50 divided by minus 10, which is minus 2. Okay, so how do I go from this number to this number? I multiply by minus 2. So now I go 2 minus 2 to the power of 11. Okay, so that's minus 2 to the power 11 is, what's that? I can't remember. It's not minus 2, sorry, minus 5. That's minus 5, minus 5. I can't believe I made that mistake. Embarrassing, minus 5 to the power of 11. And this number is some huge number, 9765625. And it's negative because I have a negative exponent, a negative power to a odd exponent. Here, the first 3 terms, if I want to do this, I just sub right in. So I want to find T1, I just sub in here. T2, sub in here. T3, sub in there, and keep going. How about Tn for this? I want to find the general term here. Let's do this one instead of that one. Look at number 6. I want Tn. So Tn is equal to Arn minus 1. I need to know what A is and R. So A is my first term. So there's A, 64. And to get this, okay, it looks like I'm dividing. Don't divide, multiply by a fraction. So it's 32 divided by 64 is a half, 0.5 or a half. So my multiple or my rate is equal to R is equal to 0.5 or a half, up to you how you want to write that out. So Tn is equal to A, which is 64, to the 1/2 to the n minus 1, which is kind of done. But if you want to keep going with this, what you can do is look at this and say 64 is the same as 2 to the 6. 1/2 is the same as 2 to the negative 1. If you remember from before, 2 to the negative 1 is equal to 1 over 2 to the 1, which is 2 to the negative 1. So I have this all to the power of n minus 1. And I can simplify this by opening up this bracket first. So I get 2 to the 6 times 2 minus n plus 1, because the power of a power rule. And that becomes 2 to the 6. And now I add these together. So I have minus n plus 1 plus 6, which is plus 7. Okay, so I have 2 to the power of minus n plus 7, or plus 7 minus n. So that's a tricky one. This part's not so tricky. This part is. This comes up a few times in this unit, guys. So if you want to practice minimizing stuff and clearing things up, it would help. What else do we have here? Determine the number of terms in this sequence here. And now there's a typo. I don't know if this one fixed it. Yeah, okay, we're good. So A is this. R is 15 divided by 3, which is 5. 75 divided by 15, which is 5. So R is equal to 5. A is equal to 3. And I want to know how many terms are in the sequence. Same thing. If I want to know how many terms in the sequence, the same thing as asking is what term is this? So my last term is equal to that, 9375. So 9375 is equal to A, R, n minus 1. And what's n? What's the value of n? What term number is that? And I know the rest of it. I know what A is. I know what A is. A is 3. R is 5, n minus 1. I divide each side by 3. This gets tricky also. Then I end up with 3,125 is equal to 5, n minus 1. So now I got some log. You can use the logs here. Okay, so I can remember the logs from last unit. So I can go log 3,125 is equal to n minus 1 times the log of 5. And I go log 3,125, 25. Over the log of 5 is equal to n minus 1. And I throw that in a calculator, and I find out that this is equal to, give me a second here. So this is equal to 5. So 5 is equal to n minus 1. Bring that 1 over, and n is equal to 6. So this is the 6th term. N is equal to 6. And that's about it. I just got really interrupted by a fellow teacher, but that's fine. I'm above that. No, I'm just kidding. Anyway, so that's about it. So if you don't like your logs, if you don't like power rules, you're not gonna have as much fun in this section as you had in other sections. Okay, so stuff we worked on. Okay, this stuff here I know is a little difficult. The log stuff, I don't think log's that bad. Okay, so if you want to solve for this, you will need log. Anytime you have an exponent and you want to solve, you can use logs. The other thing is this: you could write this as 5 to the power of 5. You could figure out that it's 5 to the power of 5 is this, and then what you say is n minus 1 is equal to 5, and you end up right here, and you solve for n being 6. Okay. Either way, get used to logs though. It's just a powerful tool. Either way, enjoy. That's it for the first week of this stuff. We'll talk about sequences, series next, arithmetic, and excuse me, and then geometric. Take care. Bye.